Welcome to our lesson on Newton's laws of motion. Isaac Newton was a brilliant scientist who published his groundbreaking work, the Principia Mathematica, in 1687. In this work, Newton derived three fundamental laws that explain how and why objects move. Let's start with Newton's first law, also known as the law of inertia. The first law states, an object at rest stays at rest, and an object in motion stays in motion at constant velocity unless acted upon by an external net force. Inertia is the tendency of objects to resist changes to their state of motion. For example, a book sitting on a table stays still because no net force acts on it. Another example. When a car brakes suddenly, a passenger lurches forward. That's because their body's inertia keeps moving. Seat belts counteract this inertia and save lives by applying a force to stop the passenger's motion. Now let's move on to Newton's second law, which relates force, mass, and acceleration. The second law states, the acceleration of an object is directly proportional to the net force and inversely proportional to its mass. F equals ma. This means that a bigger force leads to a bigger acceleration, while a bigger mass leads to less acceleration. For example, if you push a shopping trolley with double the force, it will accelerate twice as much. Another example. A truck and a car hit by the same force. The lighter car will accelerate more than the heavier truck. A rocket launching is a great example of F equals ma. The thrust, force, accelerates the rocket, mass. Now let's explore Newton's third law, the law of action and reaction. The third law states, for every action, there is an equal and opposite reaction. This means that forces always come in pairs, an action force and a reaction force on different objects. For example, a rocket expels gas downward, action. The gas pushes the rocket upward, reaction. When you walk, your foot pushes the ground backward, action. The ground pushes you forward, reaction. A swimmer pushes water backward. The water pushes the swimmer forward. The recoil of a gun is another example. The bullet goes forward and the gun kicks backward. These three laws work together to describe all classical motion, from the smallest particles to the largest planets. Newton's laws have been applied to understand planetary orbits, tides, and even the concept of universal gravitation. However, Newton's laws have their limits. They break down at very high speeds, Einstein's relativity, and at very small scales, quantum mechanics. Despite these limits, Newton's laws still power engineering, space travel, and our understanding of everyday physics.